Assalamualaikum and a good day, everyone. We would like to present our Management Information Systems study on Nvidia Corporation. My name is George Tan Yao, and we are from Group 4. These are my group members, Kaiwan, Haris, and also Sean. So let's get started. Nvidia was founded in 1993 with a strategic vision that the PC would become a mainstream device for 3D graphics and gaming. In 1999, the company invented the modern GPU with the GeForce 256. However, its most critical strategic pivot occurred in 2006 with the release of Compute Unified Device Architecture, which is known as CUDA. This transformed the GPU from a graphics engine into a programmable parallel processor. Today, Nvidia has evolved into a full-stack platform company consisting of integrated hardware like GPU, system software such as CUDA, acceleration libraries such as TensorRT, and cloud services like DGX Cloud. This full-stack infrastructure supports all core business segments: gaming, professional visualization, automotive, robotics, and our largest growth driver, the data center division. Structurally, Nvidia operates on a fabulous model by outsourcing manufacturing to Taiwan Semiconductor Manufacturing Company, TSMC, and outsourcing packaging to OSAT partners. The firm avoids heavy fabrication capital expenditures. However, this model introduces deep supply dependency, requiring real-time cross-organizational information system to keep design and manufacturing synced across the global value web. Moving on to part A, analysis of information systems. NVIDIA's enterprise architecture is integrated across all managerial levels of the firm. At the operational tier, transaction processing system, or TPS, record and automate routine activities. This includes capturing batch sales orders for systems like the HGX Blackwell through secure EDI gateways, tracking wafer production queues at overseas foundries, and updating general financial ledgers without manual delay. At the tactical level, middle managers rely on Management Information System, or MIS, to monitor day-to-day operations. Our MIS compiles raw TPS logs into structured, recurring reports, such as weekly sales variance chart, channel inventory trackers to prevent oversupply, and average selling price to price monitors. To solve non-routine semi-structured problems, NVIDIA's Employee Decision Support Systems, or DSS. These systems utilize predictive models and sensitivity analysis. For example, when TSMC experiences advanced packaging constraints, the planner will run what-if simulations. At the strategic level, executive utilize Executive Support System, or ESS. These interactive dashboard map critical internal performance data alongside external variables, organizing them around a balanced scorecard framework. These systems below are unified by enterprise applications. SAP S/4HANA act as the central enterprise resource planning system, which is known as ERP. It helps to update financial general ledgers. Supply chain management transmit production requirements directly to supplier, where customer relationship management, managing large enterprise data center contracts, and GeForce experience. Knowledge management KMS, such as the CUDA developer portal and the collaborative Omniverse platform to help capture, store, and distribute valuable technical knowledge. I'll pass to Sean to explain the next part.
Thank you, George. Nvidia leverages information systems across its business to address the operational and strategic demands of being the world's leading AI chip company. At the core of Nvidia's operations, information systems enable the company to manage its highly complex global supply chain. One of the key business challenges Nvidia faces is rising competition. Although Nvidia commands approximately 81% of the AI chip market, rivals like AMD with its MI300X and Intel with its Gaudi 3 are directly narrowing the performance gap. Competitors are catching up fast enough that other AI chips have already been selected to deployment in infrastructure, resulting in Nvidia's customer loss. The other key business challenge Nvidia faces is custom AI chips from big tech. Nvidia's most structurally dangerous threat comes from its own customers, for example, Amazon, Microsoft, Alphabet, and Meta. The more these hyperscalers have matured their in-house chips, the less they need Nvidia, effectively funding their own displacement of it. Nvidia also faced geopolitical and export restrictions. US-China trade policy has made Nvidia's second largest market structurally unreliable. Showing billions in revenue can be erased overnight by political decisions entirely outside Nvidia's control. Other than that, Nvidia faced supply chain dependency. Nvidia's near total reliance on TSMC for fabrication concentrates enormous manufacturing risk in a single geography amid heightened US-China tensions. Any disruption to TSMC's operations would immediately threaten Nvidia's ability to fulfill its reported 500 billion order book. Lastly, Nvidia's phase shift from training to inference. Nvidia's dominance was building on training large AI models, which demands its most powerful and expensive GPUs. However, as AI matures, interference is becoming the dominant workload, one that is more cost sensitive and increasingly suited to edge devices and customer accelerators. The transition from training to inference could allow competitors to seize opportunities. NVIDIA's dominance isn't just about silicon, it's a masterclass in aligning technology, organization, and management. Technologically, they weaponize their annual product roadmap to lock in customers. By launching Blackwell Ultra with 30% performance gains and teasing Rubin and Feynman, they keep rivals playing catch up. Organizationally, CEO Jensen Huang sustains this speed by flattening operations, trimming his direct reports from 55 down to 36 to eliminate bureaucracy. Managerially, CUDA and the Omniverse act as software modes hardware rivals simply cannot replicate. Instead of fighting hyperscalers, custom chips, NVIDIA locks them in with multi-year agreements, using NVLink Fusion to make their GPUs essential in hybrid setups. Concurrently, Omniverse ecosystems integrations have grown tenfold in a single year to 82. Geopolitically, diplomacy is now a core executive function. Jin Huang personally engages the White House and the team design localized chips like the H20 and H800. Yet, Southern policy shifts remain an active risk, as evidenced by a recent $5.5 billion H20 write-off. To buffer this, NVIDIA relies on its fabless model using Blackwell's modular architecture to distribute manufacturing risks across multiple suppliers. Finally, NVIDIA is actively pivoting to capture the high-volume AI inference market. Technologically, their TensorRT software optimizes deployment, slashing GPU hours by up to 50% compared to standard methods. Organizationally, they are diversing beyond the data center into edge computing via the Jetson platform and consumer RTX lines. This transition proves that technology alone cannot win the next era. It requires management to actively steer a data center centric organization toward a high volume, lower margin workloads. I'll pass the next part to Kaiwan.
Okay, thank you, Sean. Now I would like to explain about PASI, cost-benefit evaluation of our information system. When evaluating NVIDIA infrastructure investment, we must balance both quantifiable financial metric and qualitative organizational impacts. Looking at our costs, the tangible investment are significant, led by licensing fee for core platform like SAP S/4HANA ERP, Salesforce CRM, and Siemens PRM, along with massive utility bills for supercomputing power and cooling. Intangibly, we must account for the friction of workflow disruption and the training overhead that temporarily redirects engineering hours away from active R&D. However, the returns are substantial. Tangibly, our simulation system allows us to test and catch GPU layout flaws virtually before physical manufacturing, while real-time SCM tracking with TSMC slash our inventory holding costs. Intangibly, this system acts as a single source of truth, labels schematics globally without version conflicts, while advanced access control keep our highly converted intellectual property secure. Okay, next, we apply Porter 5 forces model. First, we defend against traditional rivals like Intel and AMD, not just with physical hardware, but through our 20+ year CUDA software mode. Second, the threat of new entrant and custom chip from big tech is countered by offering an all-in-one platform combining custom hardware, software library, and InfiniBand networking. Third, we neutralize potential substitute through continuous technological evolution. Fourth, we balance the immense buying power of cloud hyperscalers by building direct relationship with enterprise clients via DGX Cloud. Finally, we manage supplier power with TSMC through long-term financial prepayment and deep strategic alliance, ensuring we secure advanced fabrication nodes. Next up, our internal value chain is enhanced by MIS at every step, where R&D simulation tools accelerate our time to market and SEM logistics minimize physical shipping delays. Externally, we expand this into a highly synchronized value web using live IP links to connect NVIDIA directly with suppliers. The takeaway is clear. This zero-friction coordination allows us to run a fabulous operating model with minimal physical inventory. As network economic, as more developer write code in CUDA, enterprises are compelled to buy Nvidia hardware to run that software, which in turn encourages more developers to learn CUDA. Lastly, Nvidia acts as a foundational platform keystone for industry across industry simulation, automotive, and healthcare. Okay, to conclude, Pasi, we'll analyze how this component translate into a sustainable competitive advantage under the VRIO framework. First, while competitors can attempt to match or outspeed our physical hardware, they cannot easily replicate 20 years of optimized software libraries and developer habits that are deeply embedded globally. Second, our value web module enables real-time integration with TSMC and packaging partners, giving us unmatched speed and agility without the massive capital expenditures of owning a physical factory. Finally, according to transaction cost theory, our integrated SCM system allows us to outsource manufacturing safely and efficiently without losing operational control. According to agency theory, real-time collaborative tracking system allow us to monitor and align globally dispersed engineering teams as our enterprise skills. Okay, now I will pass to Haris to explain the next part.
All right. Moving on to part D, I will cover the security, ethical, and social implication for Nvidia. So let's start with security first. So because of Nvidia's information systems hold highly valuable intellectual property, they are a prime target for cyber attacks, such as during 2022, the hacking group named Lapsus breached Nvidia's network and leaked 1 terabyte of sensitive data, including driver source codes and chip blueprints. Nvidia also faces supply chain risks. Operating on fabless model, they rely heavily on shared digital network with partners like TSMC. A breach here could completely freeze the production of their Blackwell and H100 GPUs. To fix this, we recommend NVIDIA to enforce a strict zero trust architecture and deploys AI-driven threat detection to secure their partner networks. Let's look at the ethical implication of NVIDIA's massive computing power. So the first issue is algorithmic bias. NVIDIA core AI frameworks like CUDA, if the datasets used to train models on NVIDIA hardware contains human bias, the AI will amplify discrimination if critical areas like hiring or law enforcement. The second issue is the misuse of technology. So powerful NVIDIA GPUs can be weaponized by bad actors to create hyper-realistic deepfakes, spread misinformation, and run invasive surveillance system. So therefore, we recommend that NVIDIA establish an independent AI ethics and advisory boards and embeds digital watermarking into their hardware to prevent the creation of unauthorized deepfakes. Okay, finally, let's address the social implication. First, we see massive labor market displacement. The rapid rise of AI automation, driven entirely by NVIDIA's hardware, is replacing jobs and causing high social anxiety in creative and administrative sectors. Second, there is a heavy environmental cost. So high density data centers packed with power hungry NVIDIA's GPUs. So it requires enormous electricity and water for cooling, which inflates global carbon footprints. So to solve these problems, NVIDIA should expand its CSR programs to fund global IT upskilling. Environmentally, they must continue implementing green computing, such as the direct-to-chip liquid cooling systems, engineered into their new Blackwell architecture to maximize their energy efficiency. So that concludes my presentation for part D. Thank you.
In a nutshell, NVIDIA's market dominance proves that in the digital era, long-term competitive advantage relies on tightly aligning information system with corporate strategy and management vision. By integrating core technologies like SAP S/4HANA ERP, real-time SCM tracking, and the massive CUDA software platform, NVIDIA efficiently runs a multi-billion-dollar fabless supply chain protected by an unparalleled developer ecosystem to maintain this momentum against rising competition, geopolitical shifts, and single-source bottlenecks. The company must proactively transition to zero-trust security architectures, distribute supply chain risks, and prioritize energy-efficient hardware designs. Overall, this case study demonstrates that physical silicon alone cannot sustain leadership. True market dominance requires a unified enterprise architecture that transforms operational challenges into massive network-driven competitive modes. That's all from us. Thank you.